Greetings, Double O Boo. Your mission, should you choose to accept it, is to complete number 7. Show how to divide this expression with synthetic division. Good luck, Captain.
Thank you. Here we go. What we have here is your classic synthetic division problem where you know one of the roots. How do you know one of the roots? Well, they're telling you to divide by x plus 4. And if they're telling you to divide by x plus 4, we would assume that the opposite of positive 4 is a root, negative 4. Okay? With synthetic division, let me rephrase. With long division, x plus 4 would go out here, while the polynomial 2x cubed blah, blah, blah goes in there. Well, if x plus 4 is a valid factor of this, then negative 4 would be a valid root. Let me say that again. If x plus 4 is a valid factor of this polynomial, then negative 4 would be one of its zeros or one of its roots. So negative 4 would be one of those suspects that we captured. Okay. So negative 4 being under arrest would go into this little jail. Remember this from yesterday? Do you remember this from yesterday? Okay, good. So negative 4 is the number inside the box. The other numbers come from the coefficients of the polynomial that you're dividing. From left to right, what are they? Let's pause. There was a moment of zeroness. Somebody wanted to say 0. There's no 0. This number in front of the x squared is understood to be 1. Where you would have to hold a 0 would be if the x squared wasn't even there at all. You would need to hold its spot with a 0. All right. Okay, good. So let's go ahead and do the synthetic division process, and it goes like this. You put a line under here with some space because you're going to have to put some numbers above the line. The first step in the process is to drop the 2 down and multiply. Negative 4 times 2 is negative 8. Add. Negative 7. Multiply. Positive 28. Add 3. Multiply. Negative 12. Add 0. Good? Yes. The 0 is free to go, but the rest have been captured. Well, the rest are the coefficients of the other factor of this polynomial. You see, what we just figured out was, and I'm going to do this bold part at the bottom now. We just figured out that this polynomial, let's call it p of x for polynomial, can be split up into its divisor and its quotient. That's what they're talking about here with d of x times q of x. So that polynomial can be split up into its divisor. Well, if negative 4 is a root, what's its first factor? X plus 4. Remember, it's the opposite. And the other factor comes from the bottom of the synthetic division right there. And here's how we decode this. This is like a secret code. Here's what happened. You see, this first column was the x cubed column. But by the time you get to the bottom, it's actually now what? The x squared column. So 2 is our coefficient with x squared. The 1 was in the x squared column, but by the time you get to the bottom, now that coefficient is with x. You take each degree down 1, or each exponent down 1, minus 7x, because there's a minus 7. Okay? The negative 25 was in the x column. Now it's the constant, plus 3. And the constant that we had is now gone because our remainder was 0. If there was a remainder, you would have to add it onto the end and put it over the divisor. More on that in Unit 8.